Hi all, welcome back to another session of Ballchem Tutor. In this session, I am discussing about the structural determinations of different types of metallic clusters. So in the last session, we have discussed how to find out the number of skeletal electrons or framework electrons of different class of boranes or carboranes by using weight rules. And after finding the number of skeletal electrons and finding the skeletal electron pairs, we can find out the cluster type by Weights rules. In this session, I am discussing mainly how to find out the cluster type of different metal cluster by some tricks. So to find out the cluster type of different types of metal cluster, the first step we have to follow is to find out the total valence electron count of that metal cluster. Then next second step to be followed is that we have to find out the polyhedral electron count of that metal cluster by using the formula. It is polyhedral electron count is equal to total electron count, that is total valence electron count minus 12 into n, where n is the number of metal atom in that cluster. Then after finding the polyhedral electron count, we have to find out the polyhedral electron count pairs. And this polyhedral electron count pairs can be obtained by dividing the polyhedral electron count by 2. So after finding the polyhedral electron count pairs, we have to follow the same conditions of the Weights rule. That is, if n is a number of the metal cluster and if it is in the form of an n plus 1, that is, if our polyhedral electron count pair obtained is in the form of an n plus 1, it will be in the form of a closure type metallic cluster. Again, if it is in the form of n plus 2 means it will be nido, and if it is in the form of n plus 3 means it will be arachno, and if it is in the n plus 4 means hypo, and if it is in the form of n plus 5 means it is clado type metallic cluster. So let us do some example. That is, first question is assign the structure of RS6CO16. And options are given, that is A option is arachno, and B option is nido, and C option is closo, and D option is hypo. And so in this metal cluster, that is RH6CO16, here RH, that is rhodium, belongs to the group of cobalt. That is, cobalt is the first element, and then rhodium, then iridium. So cobalt is having the outermost valence electron, that is 3d 7 and 4s2. That means total valence electron will be 9. Same will be in the form of rhodium as well as in the iridium. So the total valence electron in the rhodium also, it will be 9. So total valence electron count can be calculated as, that is 9 into, here 6 metal atoms are there, so 9 into 6 plus, again each carbonyl group. Carbonyl group is bonded to this rhodium by its lone pair electron. That is, 2 lone pair electrons are present in this carbonyl group. So it is giving to the rhodium to form a bond. So each carbonyl group is sharing 2 electrons. So the valence electron can be found out by 9 into 6 plus 16 carbonyl group are there. Each carbonyl group will give 2 electrons. So 16 into 2. So altogether we are getting 54 plus, that is 32. That will be equal to 86. So after getting the total electron count, that is total valence electron count, we have to find out the polyhedral electron count. And this polyhedral electron count can be found out by taking the difference between total electron count minus 12 into n. That is, total valence electron count we are getting is 86 minus 12 into, here number of metal atom is 6. So 12 into 6. So 86 minus 12 into 6, that is 72. So altogether we are getting, that is 14. So 14 is the polyhedral electron count. That is electrons, total electron. So then we have to find out the pairs. So pair can be, polyhedral electron count pairs can be obtained by dividing by 2. So 14 by 2, it will be equal to 7. So that is a polyhedral electron count pair, and here the number of metal atom in this cluster is 6. So on adding 1 to this 6, we are getting that polyhedral electron count pair, that is 7. So it is in the form of an n plus 1 type. N plus 1 type means it will be equal to closure type clusters. So option is C. So let us move to the next question, that is assign the structure of OS5CO15C. But options are given, that is A option is clado, B option is closo, and C option is arachno, and D option is nido. So in this compound, that is in this metal cluster OS5CO15C, OS belong to the iron family. So iron outermost electron is 3d6 4s2, that is total valence electron will be 8. Similarly, ruthenium and osmium also have 8 valence electron. So iron family, iron first, then ruthenium, then osmium. So osmium also have 8 valence electron. So first step is the total valence electron count. So total valence electron can be find out by, here 5 osmium are there. So 5 into 8 plus 15 into 2. That is, each carbon I give 2 electrons. So 15 into 2 plus again one carbon is there. Carbon valence electron is 4. So plus 4. So 40 plus 30 plus 4, that is 74. Then after getting the total valence electron count, we have to find the polyhedral electron count. So polyhedral electron count can be find out by total electron count minus 12 into n. So here n value is equal to 5, that is metal atom present is 5. So total electron count is equal to 74 minus 12 into 5. So 74 minus 60. Again it will be equal to 40. So after finding the polyhedral electron count, we have to find out the pairs by dividing by 2. So 14 by 2, that is equal to 7. And here the number of metal atom is equal to 5. So on adding 2 only, we are getting the polyhedral electron count pair, that is 7. So it is in the form of an n plus 2 type. So n plus 2 is a conditions of a nido type metal cluster. So OS5 CO15 C belongs to a nido metallic cluster. So option is D option. So moving to the third question, that is assign the cluster type of OS3CO12, that is options are given, that is hypo, first option, then second option is closo, then C option is arachno, and D option is nido. So in this type of metal cluster, that is OS3CO12, that is OS belong to the iron family. So total valence electron will be 8. So on finding the total valence electron count, we can take it as, that is 3 into 8. Because 3 metal atom are there, each will give 8 electrons. So 3 into 8 plus 12 carbonyl group are there, each will give 2 electrons. So 12 into 2. So it will be equal to 24 plus 24, that will be equal to 48. So after getting the total electron count, we have to find out the polyhedral electron count. And it is by the formula total electron count minus 12 into n. So here total electron count obtained is 48 minus 12 into 3. N is the number of the metal atom present in that cluster, so n is 3. So it is 48 minus 36, that will be equal to 12. So after getting the polyhedral electron, then we have to find out the pairs by dividing by 2. So that is 12 divided by 2, that is equal to 6. Here the number of metal atom is 3. On adding 3 only, we are getting the polyhedral electron count pair, that is 6. So it is a form of n plus 3 type. N plus 3 is a condition of an arachno type metal cluster. So OS3CO12 belong to an arachno type metal cluster. So option is C. So moving to the next question, that is assign the cluster type of OS5CO16, and here options are given, that is A option is hypo, B option is closo, and C option is arachno, and D option is nido. So in this type of metal cluster, that is OS5CO16, again metal atom is osmium. So valence electron will be 8 because it belongs to the iron family. Iron is having the say 8 valence electron. Similarly, osmium also have 8 electron. So total valence electron count can be find out by, that is 5 into 8 plus again 16 carbonyl group are there. So each will provide 2 electrons. So 16 into 2. So 40 plus 32, that will be equal to 74. So after getting the total electron count, we have to find out the polyhedral electron count. So polyhedral electron count can be find out by the formula, that is total electron count minus 12 into n. So total electron count is equal to 72 minus 12 into, that is 5, that is 60. So we are getting the polyhedral electron count as 12. So after getting the polyhedral electron count, we have to find out the pairs, that is by 2, dividing by 2. That is 12 divided by 2, that will be equal to 6. Here the number of metal atom is 5. So on adding 1 only, we are getting 6. So it is a type of n plus 1. So it is a type of a closed type metal cluster. So option is B. So moving to the next question, it is an important question which has come in CSIR as well as a GATE exam. That is, assign the structure of Cp2CO2B4S6 and options are given. That is, A option is closo, then second option is clado, then third option is nado, and last option is arachno. So in this compound, that is, it is a type of mixed type cluster, that is, it consists of metal as well as the boron. So first step is to arrange in terms of boron. Arrange that metal cluster in terms of boron. So first we can represent that Cp, that is Cp cyclopentadienal. It gives 5 electrons to that metal cluster. So Cp and Co can be written as together, that is CpCO whole twice. Then altogether it will be Cp2 and CO2. So CpCO whole twice we can write, and then we can find out the valence electron. That is, eCp will give 5 electron and CO it is having the 9 valence electron. So on adding, that is 9 plus 5, it will be equal to 14 electron. So if it is a 14 electron, means that we can arrange in terms of BH unit as, that is, the group to be replaced is that BH. So CpCO can be replaced as BH in terms of boron. So again, if we are getting the total electron count as 15 electron means we can replace it by BH2. If it is 16 electron means we can replace it by BH3. In the same way, we have discussed in the classifications of boranes and carboranes as, if any carbon family or if any nitrogen family or if any oxygen family element is coming in boranes or carboranes, we are replacing that carbon family as BH unit. It is 14th group family, that is means it is having 4 valence electron, and the group we are replacing that carbon family element are replaced by, in terms of BH, the boron as BH unit. Again, if it is a nitrogen family means it is having 5 valence electron. So if any nitrogen family element is coming in boron means we are replacing that nitrogen element as BH2. Similarly, if it is a 16th group family, that is oxygen family means, if it is coming in the boron means we are replacing it by BH3. Similarly, if there is a 14 electron means the group to be replaced is BH. And if it is a 15th electron means the group to be replaced is BH2. And if it is 16th electron means we are replacing as BH3. So here we are getting 14 electron, that is CpCO, we are getting the total valence electron, that is 40. So the group to be replaced is BH. So we are rearranging that Cp2CO2B4H6 as BH whole twice B4H6. So we are getting total boron as B6 and H8. Then after getting in terms of boron, we have to find out the skeletal electron by Wade's rule. So according to the Wade's rule, we can split it as in the form of BH unit as BH whole 6 and additional hydrogen atom can be kept outside. That is 2 hydrogen will be kept outside. So BH whole 6 H2. Each BH unit will provide 2 electrons for the skeletal structure or framework of boranes or carboranes according to the Wade's rule. So here there are 6 BH units, so it will be giving 2 electrons. So 6 into 2 plus again additional hydrogen atom give 1 electron. Here 2 additional hydrogen atom are there plus 2. So the skeletal electron can be find out as, that is 6 into 2 plus 2, that will be equal to 14. So after getting the skeletal electron, we are dividing by 2 to get the skeletal electron pair, that is 14 by 2, that is equal to 7. So here number of boron atom, total number of boron atom is 6. So on adding 1 only we are getting the skeletal electron pair, that is 7. So it is a type of N plus 1 type. N plus 1 is a condition of a closed loop. So Cp2CO2B4H6 belong to a closed loop type metallic cluster. So option is A. So moving to the similar type of a question, that is assign the cluster type of Cp4Ni4B4H4. Here options are given, that is first option is hypo, second option is clado, then third option is nado, then last option is arachno. So here Cp4Ni4B4H4, it is again mixed type of cluster, it contains metal as well as the boron unit. So first step is to arrange in terms of boron. So this CP4Ni4 can be written as CpNi whole 4. Again, finding the total valence electron, each cyclopentadienal give 5 electron. And again, nickel, it is having 10 valence electron, that is nickel outermost shell have, that is 3d8 and 4s2. So total will be 10 valence electron. So again, total electron count will be 5 plus then 10, that is total it will be 15. Again, if it is getting 15 electron means the group to be replaced, that is the boron unit to be replaced is BH2. So CpNi whole 4 can be replaced as BH2 whole 4. So CP4Ni4B4H4 can be written in terms of boranes as BH2 whole 4 B4H4. So total boron atom will be B8 and hydrogen atom will be 12. So B8H12. Then next is to find out the skeleton electron by using the Wade's rule. So B8H12 can be split as, that is BH whole 8 and remaining 4 hydrogen atom can be kept outside. So according to the Wade's rule, each BH unit provides 2 electrons for the skeletal structure of boranes, and again hydrogen, each additional hydrogen atom provide 1 electron. So BH whole 8 means 8 into 2 plus again 4. So 16 plus 4, that will be equal to 20. That is the number of skeletal electrons. So after getting the number of skeletal electrons, we have to find out the pairs by dividing by 2. So 20 divided by 2, that will be equal to 10. So here the number of boron atom, total number of boron atom is 8. So on adding 2 only we are getting the skeletal electron pair, that is 10. So it is a form of an n plus 2 type. So CP4Ni4B4H4 belong to a nido type cluster. So option C is correct. So moving to the another question, that is assign the cluster type of C2B4H6 PTPET3 whole twice. So here metal is platinum. Platinum belong to the nickel family. So it is having total 10 electron, that is 10 valence electron. Again PET3, that is triethyl phosphate. It is a neutral ligand and it share 2 electron for the formation of a bond in a metal cluster, same like that of a carbonyl group. So again here PTPET3 whole twice can be arranged in terms of borane as, that is PT valence electron is 10, again 10 plus, again each PET3 give 2 electron. So 10 plus 4. So that will be equal to 14 electron. So 14 electron means the group to be replaced in terms of borane is BH. So it will be C2B4H6, again that PTPET3 whole twice can be split replaced as in terms of borane as BH. So it will be C2B5H, again it will be total, it will be equal to H7. So again after getting this, we can have to split in terms of CS unit and BH unit according to the Wade's rule to find the skeletal number of electrons. So it can be split as CH whole twice and BH whole 5. Again each CS unit will provide 3 electrons for the skeletal structure, and again each BH unit provide 2 electrons. So here the number of skeletal electron will be, that is 2 into 3 plus 5 into 2. So 2 into 3, that is equal to 6 plus 5 into 2, that is 10. So 16 will be the number of skeletal electron. Then after getting that, we have to find out the skeletal electron pair. So it will be 16 divided by 2, that is equal to 8. So here total number of the boron and carbon in this carborane is 2 plus 5, that is equal to 7. That is n is equal to 7. So again on adding 1 only we are getting the skeletal electron pair, that is 8. So it is a type of n plus 1. N plus 1 is a condition of a closure type. So this C2B4H6 PTPET3 whole twice belong to a closure type cluster. So option is A. So coming to the next question, which has asked in CSIR, that is total valence electron count and structure type adopted by, that is Fe5CO15C. R options are given, that is 74 and nido, first option. B option is 60 and closo. Then third option is 84 and arachno, and D option is 62 and nido. Here that is a metal type cluster, so iron belong to having 8 valence electron, that is 3d6 4s2. So total it will be 8 valence electron. Again, total electron count can be find out by here 5 iron atom are there. So 5 into 8 plus 15 into 2. Again, carbon is having 4 valence electron plus 4. So it will be 40 plus 30 plus 4. That will be equal to 74. Again, to find out the type, that is cluster type, we have to find out the polyhedral electron count. So it will be equal to, that is total electron count, we are getting 74 minus 12 into n is number of the metal atom. Here number of metal atom is 5. So 74 minus, that is 60, that is equal to 40. Then after getting that polyhedral electron count, we have to find out the pairs, that is by dividing by 2. So 14 by 2, that is equal to 7. So here n, that is number of metal atom, is 5. On adding 2 only, we are getting the polyhedral electron count pair, that is 7. So it is a type of n plus 2. N plus 2 is a condition of a Nido. So option, that is A, that is 74 is the total electron count we have obtained, and Nido type cluster we have obtained by using the finding the polyhedral electron count pair. So option A is correct. So till now we have discussed which type of metal cluster it belongs, that is whether it is closo or whether it is arachno or whether it is nido, hypo or clado. So next is to identify the shape of that metal cluster, that is if it is closo means that closo metal cluster belong to which shape or which structure it belongs. So again there are some tricks to find out the structure of that metal cluster. So this is a table we have to remember in our mind. So first, after finding a polyhedral electron count or skeletal electron pair of the metal cluster or boranes or carbonanes, then we can assign the structure. So if the polyhedral electron count pair or if the skeletal electron pair count is 6, then the preferred geometry is trigonal bipyramidal. At that time, the number of vertices should be 5. Number of vertices means the number of metal atom present in that metal cluster, or if it is a borane means number of boron atom present in that metal boranes, or if it is carbonanes means number of carbon and boron atom present in that carbon. Again, if the skeletal electron pair is 7 and at that time number of vertices is 6, then the preferred geometry can be octahedron or trigonal prism. And again, if the polyhedral electron count or pair or skeletal electron pair obtained is 8 means the preferred geometry is pentagonal pyramid. Again, if it is 9 means the more geometry are favorable. That is, one it is dodecahedron and second is trigonal prism, that is bicapped trigonal prism, and hexagonal geometry can be obtained or cubic structure can be obtained. So this when polyhedral electron count obtained is 9 means it is much more important. Thus we have to assign which structure it belongs. Again, if the polyhedral electron count pair obtained is 10, then the preferred geometry is tri-capped trigonal prism. And if it is 11 means it is bicapped square antiprism. And if it is 12 means it is octadodecahedron. And if it is 13 means it is icosahedron. So when we look the vertices and the skeletal electron pair of this table, we found that on adding 1 to these vertices, we are getting the skeletal electron pair. That means it is in the form of n plus 1. So all this table, that is all this structure is perfect for a metal cluster belonging to a closo type. So when we are getting the skeletal electron pair and if it is getting the vertices more than or less than that is if it is nido or if it is an arachno type, what will happen to the structure? There will be some change in the structure because this table is perfect for a metal cluster belonging to a closo type. So there will be some change in the structure. So what happened to the structure we can check by taking some detailed example. So let us move to one example, that is one question, that is assign the structure of Pb102 minus, and in that option has given, that is first option is trigonal prism and second option is bicapped square antiprism and third option is octahedron and D option is icosahedron. So first step is to find out the polyhedral electron count, and here let PB is lead belong to the group 14th family. So group 14 family means 4 valence electron will be there, and 4 valence electron means we have to replace in terms of boron as BH. So PB10 can be, that is each PB can be replaced as BH. So it can be written as BH whole 10 2 minus. Then according to Wade's rule, we have to find out the number of skeletal electron and skeletal electron pair. So we can find the number of skeletal electron as each BH unit provide 2 electrons. So 2 into 10, again negative charge, each negative charge contribute 1 electron. So 2 into 10 plus 2. So that will be equal to 22. So after finding the skeletal electrons, we have to find out the pair. It is 22 by 2, that will be equal to 11. So here we are getting the polyhedral electron count or skeleton electron pair obtained is 11. At that time, the number of vertices should be 10. Then only the preferred geometry is bicapped antiprism, square antiprism. Here we are getting the vertices correct, that is n is equal to 10, and because 10 lead atom are there and skeletal electron pair obtained is 11. So that it belongs to a closure type, and again I have discussed the table which is perfect for a closure type structure. So here the geometry can be bicapped, square antiprism. So the option is B. So moving to the second question, which is very important, that is assign the structure of PB8 6 minus. In that option has given, that is A option is octahedron and B option is trigonal prism and C option is square antiprism and D option is hexagonal. In this case also lead belong to the group 14th family, that is, so lead has 4 valence electron and the group to be replaced in terms of boron is BH. So each PB are replaced as BH. So here there are 8 PB, so BH whole 8 6 minus. Then according to Wade's rule, we can find out the number of skeletal electrons. So 8 into 2, because each BH unit contribute 2 electrons, so 8 into 2 plus again there are 6 negative charge, each negative charge contribute 1 electron, so plus 6. So 8 into 2 plus 6, that means total will be 22. So skeletal electron pair can be found out by dividing by 2, that is 22 by 2, that will be equal to 11. Here the polyhedral electron count or skeletal electron pair obtained is 11, but the vertices is only 8. Perfect, that is if n is equal to 10 and if skeletal electron pair obtained is 11 means at that time only we have this geometry, that is bicapped, square antiprism. Here vertices is 2 minus, that is n is equal to 8 only. So it should be 10, that only it can be preferred geometry is bicapped, square antiprism. So 8 means we can't change the perfect geometry, that is square antiprism. We can remove the capping. So how many capping we have to remove is, first for one capping it will be again at that time vertices will be 9. If again one more capping is removed means, that is there is no capping means it will be perfect square antiprism. At that time vertices will be correct and is equal to 8. So the preferred geometry can be square antiprism, that is capping can be removed, but square antiprism will be perfect. So the option is C. So coming to the next question, that is assign the structure of B9H9S, that is S is sulfur, and here options are given, that is A option is trigonal prism and B option is bicapped square antiprism and C is octahedron and D is icosahedron. In this compound also it is a boron and here one sulfur is there, that is sulfur belong to the 16th group, that means it is having a 6 valence electron, and in terms of boron we have to write means the sulfur group can be replaced in terms of boron as, that is BH3. So it can be written as B9H9S can be written as B9H9BH3. So altogether it will be B10H12. So again according to Wade's rule we can find out the skeletal electron count. That is first we have to assign in terms of BH unit, that is BH whole 10 and 2 hydrogen will be left, it will be kept outside. So H2. So each BH unit contribute 2 electrons, so 2 into 10 plus again 2 hydrogen atom 2. So total skeletal electron pair, count is equal to 22. So skeletal electron pair will be dividing by 2, that is 22 by 2, that will be equal to 11. And here the polyelectron count or skeletal electron count pair obtained is 11. And here vertices also n is equal to 10. So it is a closure type. So perfect geometry will be obtained. So if n is equal to 10, that is vertices is 10, and polyhedral electron count pair obtained is 11, means again it is a bicapped square antiprism. So B9, S9, S belong to the bicapped square antiprism, that is option is B. So moving to the next question, which is also very important. It has came in GATE exam. That is, assign the structure of Bi5 3 plus. And here bismuth 5 3 plus options are given. That is, A is diagonal bipyramidal, and B option is bicapped square antiprism, and C option is octahedron, and D option is icosahedron. And here bismuth belong to a 15th group family, that is 5 valence electron in their outermost shell, that is nitrogen family. So it should be replaced in terms of BS unit as BH2. So Bi5 3 plus can be replaced in terms of BS unit as BH2 whole 5 3 plus. So that means altogether the boron atom will be B5H10 3 plus. Again, according to Wade's rule, we can find out the skeletal electron and skeletal electron pair. So each BH unit contribute 2 electrons, so 2 into 5 plus again additional 5 hydrogen atom will be there plus 5. Again here there is a positive charge plus 3, that means we have to reduce, that is minus 3. So 2 into 5 plus 5 minus 3, so altogether it will be 12. So after getting the skeletal electrons, we have to find out the pair by divided by 2, that is 12 by 2, that is equal to 6. So here the skeletal electron pair obtained is 6. At that time vertices should be 5. From the table, if it is closer means vertices obtained should be 5, and if it is 6 means at that time the perfect geometry is diagonal bipyramidal. So here n is also equal to 5 because the bismuth obtained is 5. For boron atom, after replacing to the boron also, the boron atom obtained is 5. So n is equal to 5, and again polyhedral electron count pair or skeletal electron pair obtained is 6. So the perfect geometry is diagonal bipyramidal. So option is A. So moving to the next question, which is a most confusing question, that is, assign the structure of ReH9 2 minus. It has came in GATE as well as in the CSIR exam, that is near 2019, I think. So option is A, tricapped trigonal prism, and bicapped square antiprism, and C option is octahedron, and D option is icosahedron. In this compound, one important point to note is that here metal atom is radium, but there are 9 hydrogen atoms, and that hydrogen atom is acting as a vertices. That is, 9 hydrogen atoms are acting as a vertices. But the radium is present in the somewhere in the interstitial site of that metal cluster. So here we have to count the hydrogen. That is because hydrogen is acting as a vertices. So we have to find out the total electron count, that is total valence electron count. Here radium means it belongs to the manganese group, that is manganese, technetium, rhenium. So the total valence electron present in the rhenium will be 7 because manganese have outermost electron 3d5 4s2. So similar for the rhenium also. So rhenium, it is having the 7 valence electron. Then each hydrogen atom 1 electron, so 1 into 9. So 9 plus again there are 2 negative charge, so plus 2. So total will be 80. And again when we are counting the polyhedral electron count, it will be total electron count minus 12 into n. Here number of metal atom is 0 because we are already told that hydrogen is acting as a vertices. Rhenium is acting present in the interstitial site of this cluster. So the number of metal atom is 0. So 18 minus 12 into 0, that will be equal to 80. So polyhedral electron count pair will be 18 by 2, that will be equal to 9. So here number of polyhedral electron count pair obtained is 9. At that time the vertices should be 8. Then only we can have so many structures, that is dodecahedron, then hexagonal, then cubic, it can be bicapped trigonal prism. So which geometry it belongs, we have to predict. So dodecahedron means it should have 12, that is dodeca means it has 12 vertices, so it can't be possible. Then again hexagonal means it can be 6. So here also 9 vertices are there, it cannot be possible. Cubic means it is perfect for cesium chloride like structure. It's alkali metal, that that is cesium chloride structure, so it can't be possible. Last geometry, that is bicapped trigonal prism. It can be possible. Again, at that time vertices should be 8. Here vertices, that is n is equal to 9 because there are 9 hydrogen atoms which are acting as the vertices. So n is equal to 9, that is 1 extra is there. So we can't change the trigonal prism, but capping we can introduce. So bicapped trigonal prism is suitable for when a polyhedral electron count pair obtained is 9. Here vertices is 9 means one more capping we can introduce, so it can be capped trigonal prism. So option will be A. So coming to the next question, that is assign the structure of OS10 CO24 C2 negative. Here option has given, that is A option is tricapped trigonal prism, B option is bicapped square antiprism, C option is tetracapped octahedron, and D option is icosaedron. So in this compound, it is OS10 CO24 C2 negative. Here osmium belong to the iron family. So osmium is having 8 valence electron, that is iron family is having 8 valence electron in their outermost shell. So osmium also having 8 electron in the valence shell. So total electron count will be 8 into 10 plus 24 into 2, that is each carbonyl give 2 electrons. So 24 into 2 plus carbon is having 4 electron in the valence shell plus 4 plus again 2 negative charge plus 2. So total will be equal to 134. So after getting the total electron count, we have to find out the polyhedral electron count. It will be equal to total electron count minus 12 into n. 12 into n, here it is 10. So 134 minus 12 into 10, that is 120, that will be equal to 40. So after finding polyhedral electron count, we have to pair it. That is 14 by 2, that will be equal to 7. So if the polyhedral electron count obtained is 7, means the preferred geometry is octahedron. At that time vertices should be 6, but here vertices obtained is 10, that is there are 10 osmium atoms, that is 10. So we are getting 4 extra. So we can't change the geometry, that is actual geometry octahedron, but we can introduce capping. So how many capping we have to introduce? That is 6 to 10, that is 4 capping we have to introduce. So it can be tetra-capped octahedron. So option will be C. So coming to the last question, that is assign the structure of OS10 CO24 C6 negative. Here options are given, that is A option is tetracapped trigonal prism, and B option is bicapped square antiprism, C option is tetracapped octahedron, and D option is icosaedron. So in this compound, it is osmium metal atom which belong to the iron group, that is iron is having 8 electrons. Similarly osmium also having 8 valence electron. So total electron count, that is total valence electron count, can be find out as 8 into 10 plus again each carbonyl group produces 12 electrons, share 12 electrons. So 24 into 2 plus carbon have valence electron 4, so plus 4 plus again negative 6, that means adding plus 6. So it will be total, it will be equal to 138. So after getting total valence electron count, we have to find the polyhedral electron count. So polyhedral electron count will be equal to 138 minus 12 into n. Here number of metal atom is 10. So 12 into 10. So 138 minus 12 into 10, that is equal to 18. So pairing, we will get 18 by 2, that will be equal to 9. So if the polyhedral electron count pair obtained is 9, means there are more geometry, that is dodecahedron, hexagonal, cubic, and bicapped trigonal prism. More convenient geometry among this is bicapped trigonal prism, but the vertices obtained should be 8. But here vertices obtained is 10, it is 2 extra. So trigonal prism is actual shape, but we can introduce 2 more capping. So it will be bicapped, tricapped, tetracapped. So tetracapped trigonal prism. So option is A. So that is all in this session. Hope you like the session. Stay tuned for the next session. Till then, bye.